Yes, today we discuss that is a geometrical isomerism. What is that? Geometrical isomerism, right? Geometrical isomerism means that is a cis and a trans. What is that definition of geometrical isomerism? The isomers. I will write down that. Hemalata, please wait. Uploaded. Hemalata, once check it out. All classes are uploaded. Okay. Okay, what is a geometrical isomerism? Here, same molecular formula, same molecular formula, but different, spatial arrangement. Spatial arrangement. That is called geometrical isomerism. Is it clear? I will send you notes. Please wait. Okay, I will send you notes. Okay, through written part I will send you. Just I will explain. Same molecular formula but a different spatial arrangement of the groups or atoms, that is called geometrical isomerism. Okay, spatial arrangement of groups or atoms, that is called geometrical isomerism. For example, carbon and carbon, here A, B, then B, then A. If it is two groups are same side, what is this? What is this? Two groups are same side, that is a cis. If it is two groups are opposite direction, see A, again B, B. What is this? Trans. But we cannot convert cis to trans or trans to cis. We cannot convert. It is not possible. Cis to trans or trans to cis. Why it is not possible? Listen. I will show the video. Please listen. Okay. Now visible. Yes, visible. Yes. For example, listen. This is a top one. Here two pencils are there. Okay. One is a bottom is a sigma bond. Then top one is a pi bond. Is it clear? Sigma bond, pi bond. Okay. In between, what happened here? This is a corner. Every corner which is having the carbon. Okay. Here one group. One is A. Another one is B. Are visible? A and B. Is it clear? A and B. Similarly, here also same thing. A and B. A and B. It is that right? If it is, why it is a cis to trans is not possible? Whenever we have to rotate this one, if it is conversion of cis to trans or trans to cis, it requires rotation, right? Whenever you have to rotate the bond, what happened? To break the bond. See this one. Okay, to break the bond. Yes, whenever we have to rotate this bond. ఏదో ఒకటి రొటేట్ చేయాలి కదండి, పైది కిందికన్నా రావాలి, కింది పైకన్నా రావాలి. Then only it is a cis to trans or trans to cis. But whenever we have to rotate this bond, what happen? Pi bond will be breaking takes place. Pi bond will be breaking takes place. If it is one pi bond breaking takes place is room temperature, at room temperature, it requires 251 kilocalorie per mole of energy. It requires one pi bond breaking takes place. Carbon pi bond breaking takes place. It requires 251 kilocalorie per mole energy required. But that much of energy we cannot provide at room temperature. We are providing any temperature. Here we are providing any temperature, guys. Any temperature. We are providing any temperature. We are providing any temperature, guys. No. That's what is here. Cis to trans, then trans to cis is not possible due to this much of energy we cannot provide at a room temperature. You know that here carbon and carbon, here partial overlapping of p orbitals. Mix R cheppara idi. Then how to form the pi bond? Partial overlapping of p orbitals. Yes or no, guys? So whenever we are rotated this bond, what happen? This bond will be breaking takes place. This bond will be breaking takes place. Okay, that bond will breaking takes place, it requires 251 kilocalorie per mole. But that much of energy we cannot provide it at room temperature. That's what cis to trans and trans to cis not possible. Is it clear? Is it clear, guys? Because here, see this one. Once again, I will explain. This is a bottom is a sigma bond and the top one is a pi bond, right? If you have to rotate it like this, what happen? It bond will be breaking takes place, right? Yes or no? So here, see this one. See this one. This is the middle of the carbon, right? Okay. If it is a breaking takes place, it is rotated very easy. But we are not providing that much of energy. It requires some energy to break the bond. But that much of energy we cannot provide at room temperature. That's what cis to trans or trans to cis not possible. Is it clear, guys? Is it clear? Is it clear, guys? Chal. Right? All are understood? All are understood? Yes? Chalo. Okay, here, this is that's what here generally what happened here. Sometime I think Jashwant have to explain this one. For example, this is a carbon, this is also carbon. Anyway, it is a single bond is there. This is a sigma bond, but is a sharing of the electron. Whereas a pi bond, this is a partial overlapping of p orbitals. Yes or no? Ila untundandi partial overlapping. Yes, guys. Partial overlapping of the p orbitals. Yes. So that this is a partial overlapping. Whenever you have to rotate it, this bond, it bond breaking takes place. Why? Because this is a partial overlapping. This is a center of the carbon sharing of the electron. This is a sigma bond, but sigma bond and pi bond, which is easy to breakage while applying the energy, while applying the force. This is a pi bond because pi bond is a partial overlapping. The sigma bond is the center of the carbons, center of the element, which is sharing of the electrons. Okay, this break in tarvatane this break avutadandi. This first break kaadu because it is a more stable. Okay, stronger bond always a stronger. Is it clear? So that this whenever we have to rotate it, this bond, what happen if it is rotated sorry, see this one. If it is a carbon A B against A again B, this is a trans. If it is rotated, this is a top going to top, this is a bottom, then what happen? It turns to C. It turns to cis. But here this is a cis, this is a trans, but it is rotation is not possible because carbon single bond rotation is very easy. But whereas the double bond and the triple bond, it is restricted due to it is whenever you have to rotate this bond, this pi bond will be breaking takes place. This is a pi bond. Same thing here, pi bond will be breaking takes place. But whenever it is a pi bond breaking takes place, it requires some energy. That much of energy we cannot provide it room temperature. That's what that double bond and the triple bond always the rotation is restricted. Is it clear? Rotation is very clear. It is a restricted. It is a single bond. Carbon single bond is rotation is a very easy compared to double and triple. Is it clear? Is it clear, guys? Because here both are having the pi bonds. Here only sigma bond. Sigma bond rotation is very easy compared to pi bond because pi bonds always it forms partial overlapping of p orbitals. Is it clear, guys? Is it clear? Any doubts? Hemalata, Abhishek Joshi, any doubts? Bhuvan Samudrala, Srija Koduru, any doubts? Chalo, I will send you notes. Okay, all of you please write that entire thing. That is a theoretical thing. Whatever that we discuss, that is I will send you notes. Okay, all of you please be ready. Okay, start that writing. Is all are received? What's up? All are received? All are received? We wrote that reason also. All are received through WhatsApp. I send on notebook. Yes, geometrical isomerism, entire part. Whatever that we discuss here, this is a theoretical. You have to write down. Write down fast. If you are not understanding anything, please ask the questions. Not functional group keto enol tautomerism, that is only which is 1,3 shifting of proton. Show money that Keto-enol tautomerism, because ketone is enol, but ketone converted to aldehyde, that is a functional group isomerism. Show money. Because aldehyde and ketones are, the combination is very, it shows a functional group isomerism. Is it clear? Okay, all of you please write down. Then I will send you second page also. This is the first page, then second page. Yes, second page also you should write down before properties. What are the conditions? Conditions you have to write down. Already we discussed now. Guys, we discussed now conditions. What are the conditions? If it is carbon carbon AA both are same, it does not show geometrical isomerism. Yes or no? Last class which we discuss here. Same thing we discuss. Yes or no? Okay, do it fast. Before properties. All of you please write down before properties. I will give how much time it requires for 2 pages. How much time it requires? Yes, మొత్తం రాయాలమ్మా. శ్రీనందిత మొత్తం రాయండి. Don't leave anything. That is very, very important. Okay, it required 20 minutes. Yes, I will give 20 minutes time. All of you please do it fast. Neat గా రాయండి, ఓవర్ రైటింగ్ ఉండొద్దు. Neat గా రాయండి. Srish, please wait. I have to change the settings. Yes, Srish, again send me. Again send. Srish. Yes. Okay, I will give 20 minutes time. Do it fast. Uploaded Hemalata isomerism అని ఉంటుంది చూడు, geometrical isomerism, GI అని రాసినాను. GI isomerism అని రాసినాను. అప్లోడ్ చేశాను నేను. చెక్ చేయండి. Yes, 2 pages total completely before properties. Conditions వరకు రాయండి. Conditions. Sai Ritvik. All of you please write down all conditions up to conditions. What happened, Ritesh? Ritesh? Karthik? Karthik? Fair notes la రాయాల్సిందే వేరేదేం లేదు. Complete 2 pages, Ashok. Before properties. Before properties. Yes, finished. Finished, Andy. Yes, guys, finished. Finished, Andy. Finished, Andy. Guys, finished. Are they ready? Finished. Yes, finish it fast, guys. Fast, finish it fast. Neat రాయాలి, neat రాయాలి, over rating ఉండొద్దు. If you want 5 minutes time, I will give 5 minutes time. Don't worry. Yes, guys, finished, Andy? Finished, Andy? Yes, finished, ah? Yes, conditions are over. Conditions are over, guys. Shanmugh, do it fast. Almost 30 minutes are over. 30 minutes over. And given 20 minutes again. Again 10 minutes. Last 2 minutes. Right. Do it fast. Guys, over? Till all conditions. Yes, all conditions are over. Second page is over. No need to write down anything. Before properties. మీకు ప్రాపర్టీస్ వరకు సెండ్ చేస్తే అనుకుంటాను. బిఫోర్ ప్రాపర్టీస్ ఓవర్. చెప్పండి కంప్లీట్ అయిందా లేదా? బిఫోర్ ప్రాపర్టీస్ yes finished ah? Yes finished ah? Yes, listen. Okay, what are the conditions of geometrical isomerism? First condition, a b again b a. This is a possible. Generally this is a cis isomer. Yes, yes or no? This is the first condition. What about second condition? C C a again here b again b. Okay, see a, this is a b, this is also condition, it is satisfied. This is a trans. Okay, this is also satisfied. But whereas in this case a again b c, it is not possible because of these two are same groups are there, it is not possible. Is it clear? If it is a b c d, four groups are there, this is ez nomenclature. This is also possible. What is ez nomenclature? We discuss later. This is a c double bond n. This is a lone pair oh ch. Shall I write down r here h? This is a oh and hydrogen, it is a trans. This is we are calling as a anti, not anti. This is also possible. Okay, ఇది రాసుకోండమ్మా. If it is a C double bond N OH and H, both are same side, this is a lone pair, this is a syn. This is also possible. Okay, please write down these three. Okay, this is the third one is not possible. Again, fourth one is possible. Then fifth one is possible. Sixth one also possible. Is it clear? Is it clear, guys? Is it clear? Anti means OH and hydrogen opposite side. Here syn means hydrogen and OH is the same side because this is oxime. This is a oxime. Oximes కాబట్టి ఇలానే ఉంటాయి. ఎందుకు అలా ఉంటాయి విల్ డిస్కస్ లేటర్. నేను తర్వాతకి చెప్తాను. ఓకేనా? ఓకేనా గైస్? ఓకే, ఫినిష్డా? ఫినిష్డా? Yes, guys, finished అండి. హేమలత ఫినిష్డా? Yes, Ashok, what is that previous slide? This one means we can అక్కడ రాసాం కదా థియరీ పార్ట్. We cannot rotate at the carbon bond is restricted because of pi bond is partially overlapping. Okay, that is we explain that entire thing. Okay, unda ikkada unda whatever that we discuss unda akkada point lo raయించినామా హేమలత? It is there. Ashok, everything it is there, whatever that we discuss that one. Chalo. Yes, these are the conditions. Have you written? All are written for all 6 conditions. Once check it out whether you are written or not. Once check it out, guys, whether you wrote or not. Whether you wrote or not, once check it out, guys. Okay, Ashok finished. Shall I move next slide? Ashok, finished amma. Chalo, any doubts, guys? Now we discuss about that properties. Properties. What are the properties? Okay, the properties is, one is a melting point. We discuss melting point. Melting point. Generally, we wrote MPT, melting point. Okay. Second is a boiling point. Boiling point. This is a boiling point. Don't write down BP and write down. Okay. Third point. This is a solubility. Means which is soluble in easily అని మనం చెక్ చేయాలి solubility. Then fourth one, dipole moment. Dipole moment. Dipole moment. Then fifth one, stability. Stability, which is most stable, which we have to discuss. Okay. Okay, guys. Write down properties of geometrical isomerism. Write down, guys. Rasara. Okay, why these are shows the different properties? Due to why these given the different properties? Due to due to different arrangement of groups with respect to ఏంటిది double bond. Yes or no? Cis trans anamata. Okay, these are the properties it shows geometrical isomers. First one is melting point. Melting point. Listen. Finished off? Shall I start melting point? Yes. Melting point. Why these are, it shows a different property. Okay, here for example A so A again B, then double bond A again B. Okay, this is canonical cis, this is canonical trans. Okay, Asha, please take screenshot fast. Don't waste the time, Asha. Chalo, cis and a trans. Okay, which one is a symmetrical? Which one is a symmetrical? Symmetrical means whenever we have to cut the bond, we get equal half. Is symmetrical చెప్పండి ఇందులో? Cis or trans? Cis ఎలా అవుతుందండి? If you are cutting this bond, this is one plane, this is another plane. అవునా? Plane లో ఉంటుంది. చలో వినండి. Wait 2 minutes, I will show that. Wait 2 minutes, I will show that again video. Okay, I will show. Please wait. Okay, guys, today afternoon I will take the class. Be ready. Class తీసుకుంటానండి. Okay, chalo వినండి. Okay, this is a double one. Yes, this is a double one. Okay, cis isomer means both are same side. One is at this side. Okay, another one is this side. Is it clear? Is it clear, guys? Similarly, another isomer. This is a cis and trans. Cis, okay, cis over trans. Cis and trans. Is it clear? Is it clear? If you have to break the bond, మనం కట్ చేస్తున్నామండి. ట్రాన్స్ ని ఇలా కట్ చేద్దాం. Okay, If you are cutting the bond, we are getting equal half. If you are getting the, if you are cutting this bond, one is, this is in plane, this is out plane. Okay. For example, here see this one. This is we get a. This is we get a. Here, if you are cutting this bond, what happens? This is in plane. This is out of the plane. If you are cutting this bond, we get a two equal planes. Two equal planes. So that this is a symmetrical. This is unsymmetrical. Unsymmetrical means if you are cutting this bond, we get a two equal halves. Two equal halves. Two equal halves. If here we are not getting two equal halves, that's what it is. A cis is a unsymmetrical and a trans is a symmetrical. Is it clear? Is it clear, guys? Is it clear? Any doubts? Any doubts? Any doubts, guys? Any doubts? ఏమన్నా డౌట్స్ ఉన్నాయండి? Any doubts? So which one is a symmetrical? Which one is a symmetrical? You take any direction. If you are cutting this bond, equal. Okay, this is a symmetrical, this is a unsymmetrical. So that whenever it is a symmetrical structure, this is a packing, symmetrical packing structure. So melting point of always a melting point always trans is greater than cis due to symmetrical nature. Generally we are calling as a symmetrical packing structure. Symmetrical packing. This is unsymmetrical packing. Is it clear? So which is more? Which is more boiling? Which is more melting point? Which is more melting point? Which is more melting point, guys? Trans. Due to what you wrote? Due to symmetrical. Yes, that's enough. Due to symmetrical. Okay, write down. Write down. ఓకే, ఫస్ట్ అర్థం చేసుకోండి. నేను రైట్ డౌన్ ఏం రాస్తారు ఇక్కడ? మెల్టింగ్ పాయింట్ స్టేట్మెంట్ నేను రాస్తా చూడండి. మెల్టింగ్ పాయింట్. ఓకే, మెల్టింగ్ పాయింట్ ఆఫ్ ట్రాన్స్ ఐసోమర్ ఈజ్ మోర్ దెన్ cis. Is more than cis because of symmetrical packing of trans. Okay, is it clear? Is it clear? So always trans is more than cis. ఏదైనా ఇవ్వండి, always a trans. చలో ఫినిష్ రా. Ritesh, please raise your hand. Ritesh, please raise your hand. Ritesh. Yes, Ritesh, are you there? Please raise your hand. I will talk with you. Ritesh. Who's this? Ritesh, not Vitesh. Vitesh or Ritesh? What is your name here? Ritesh. Ritheesh. Who's this? Ritesh. Ritesh, please raise your hand. Raise your hand, otherwise I have to remove. Yes, cis unsymmetrical. Sumit, this is unsymmetrical. This is symmetrical. Is it over, guys? Over. Chalo. Next. Shall I move next slide? Melting point. So again we are going to the boiling point. Chalo. Boiling point. Boiling point. Listen. Here carbon and carbon, for example, CH3 ankondi. Like a CH3, then CH, H, 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 H. What is this? Cis-2-butene. Yes or no? C double bond, CH, H, H, then C, H, 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 H. What is this? Trans-2-butene. Cis-2-butene, correct na? Trans. Which is more boiling point? Which is more boiling point? Yes, Srish, which is more boiling point? Which is more boiling point? Always boiling point. Always cis is more than trans. The reason is presence of here steric indents. గుర్తుందా? మీకు చెప్పానా స్టీరిక్ ఇండెంట్స్ అని? ఎక్కడ చెప్పాను చెప్పండి? ఎక్కడ చెప్పాను? బేసిసిటీ ఆఫ్ అమైన్స్ లో చెప్పినాను. Here steric crowding is present, so that the cis isomer is more than trans. But here options of steric indents. Options of steric indents. So that in this case we wrote the definition. Okay, boiling points of cis isomer is more than trans due to steric hindrance. Steric hindrance is present in cis, so that this cis is always high polar. Okay, in bracket, cis is high polar compound. High polar compound. Why? Because steric hindrance is present. Is it clear? Is it clear, guys? Any doubts? Hemalata, Mrinali, Amok, Satvik Ganjal. Any doubts? Any doubts? So write down. ఏం రాస్తారు? బాయిలింగ్ పాయింట్ అని రాసి స్టేట్మెంట్ రాసుకోవాలి. ఫస్ట్ బాయిలింగ్ పాయింట్ ఆఫ్ సిస్ ఐసోమర్ ఈజ్ మోర్ దాన్ ట్రాన్స్ ఐసోమర్ డ్యూ టు స్టీరిక్ ఇంటెన్స్. సిస్ ఈజ్ ఐపోలార్ కంపౌండ్. మనోజ్, ఫినిష్ ఇట్ ఫాస్ట్. Satvik, yes, write down first. I will show that as previous slide. Okay, after class. First write down. మళ్ళీ వెనకకి వెళ్ళలేమమ్మా. Please wait for 10 minutes. 10 minutes తర్వాత చూపిస్తాను. Okay, Satvik. Any doubts, guys? Finished? Yes, finished? Over? Finished now, guys? ఈరోజు ఆఫ్టర్నూన్ కూడా క్లాస్ తీసుకుంటానండి, రెడీగా ఉండండి. ఓకే, యశ్వంత్ అయిపోయిందండి, అయిపోయిందా? ఫినిష్డా? షల్ ఐ మూవ్? ఎంఓనా? ఎంఓ ఎక్కడుందబ్బా? ఎంఓ ఎక్కడుందమ్మా? శ్రీజ, వేర్ ఈస్ ఎండో? Srija sometimes wrote this one. Where is this? ఎంఓ ఎక్కడుందమ్మా? I will send you, Hemalata. Chalo, next solubility. Solubility means you have to check it out whether it is a soluble or not. Okay, chalo, I will write down that definition. Please wait. Some of the properties also, the solubility, comma solubility, comma viscosity, then and refractive index, refractive index. These are the other properties. Refractive index of cis isomer more than trans due to high polar of చెప్పండి, high polar of cis isomer. ఇందాక చెప్పినాను, cis isomer is more polar than trans అని. So cis is greater than trans. Solubility. Is it clear? Is it clear? Hemalata, Satvik Ganjal, Srija, Bhuvan Samudrala. Chalo, write down. Yes, over. Guys, finished off. Amok. Yes. This is a take screenshot. Satvik Ganjal, this one you are asking. Melting point. Satvik Ganjal, this one you are asking this one. Last slide like that. Yes, finished off. Finished off. Guys, finished off. Yes, next one, dipole moment. Dipole moment. This is very, very important. And dipole moment, generally we are showing mu, not m. Srija Kodur, this is a mu, not m. Mu raskondi. Okay. For example, okay, I will write down that statement. In general, cis isomer, cis isomer, cis isomer, cis isomer has higher dipole moment, then trans isomer, then trans isomer, then trans isomer, then trans isomer. Okay, due to high polar of cis isomer. Is it okay? For example, C double bond CH3, then CH3 H H. Same case C CH3, then CH3, then H H. This is a cis. This one is trans. Okay, here cis is a dipole moment is not equal to 0. Ento kuntuntundi, but trans is always 0. Is it clear? Is it clear, guys? Is it clear, guys? Is it clear? Any doubts? Any doubts? So something not equal to 0 means more than 0. Here trans is always 0 because it is a symmetrical. It is symmetrical, it is unsymmetrical, or it is a polar, it is non-polar. Is it clear? Is it clear? This is a mu, not a m. M rasko dandi. This is a mu. Is it clear, guys? Generally, cis isomer dipole moment is exactly dipole moment is 0.33 d. D by. This is a non trans is almost mu equal to 0.00 d. That's what Z. No exceptions. Cis and trans will discuss aromatic compound later. One by one discuss చేద్దాం. సుచిర్ మామిడాల ట్రాన్స్ సిస్ ఎప్పుడు కూడా మీకు సిస్ ట్రాన్స్ కంపేర్ చేయమంటాడండి. సిస్ ఈజ్ ఆల్వేస్ లెస్సర్ దాన్ ట్రాన్స్. సారీ ట్రాన్స్ సిస్ ఈజ్ మోర్ దెన్ ట్రాన్స్. ఎప్పుడు కూడా మోర్ దెన్. ఇక్కడ చూడండి, విచ్ ఇస్ మోర్ cis. Cis is always higher than trans. Is it clear? Chalo, write down fast. is it dipolar due to steric indents? Steric indents, Vinay Raj. Steric indents. We wrote that point. Okay, or that is unsymmetrical or unsymmetrical. Vinay, is it okay? Is it okay? Chalo, finish now, guys. Finish, Randy. Finish now. Chalo, next, stability. I think last one. Which one is more stable? Tell me. For example, CH3, then CH3, H, H. Cis 2 butene. This is a trans 2 butene, right? This is a cis and trans. This is a cis trans. Which is more stable? Which is more stable? Yes, always a trans is more stable. In general, trans isomer is more stable than cis isomer. Because of చెప్పండి steric indents. Steric indents. If it is steric indents is present, that is less stable. This is a presence of steric indents. Here, absence of steric indents. Vinay Raj, చెప్పండి. What is our doubt? Vinay, have you understood? Have you understood? Okay, chalo. So stability, which is more? ఇక్కడ ఏందండి, ఇక్కడ రిపల్షన్స్ ఉంటాయి. స్టెబిలిటీ ఎలా ఉంటుంది? ఇది దూరం దూరంగా ఉన్నాయి కాబట్టి స్టెబిలిటీ ఉంటుంది. సో ట్రాన్స్ ఈస్ మోర్ దాన్ సిస్. ఓకే, yes, any doubts? Any doubts? Any doubts, guys? ఇంకేమైనా డౌట్స్ ఉన్నాయండి? ఎనీ డౌట్స్? చాలా. నెక్స్ట్ టేబుల్ ఇస్తాను చూడండి. దిస్ ఈజ్ అ సిస్, దిస్ వన్ ఈస్ ట్రాన్స్. ఓకే, ఫస్ట్ వన్ ఏమి ఇచ్చినానమ్మా? ఫస్ట్ ఏమి ఇచ్చిన? డైపోల్ మూమెంటా? కాదనుకుంటా. మెల్టింగ్ పాయింట్, బాయిలింగ్ పాయింట్, solubility, dipole moment, stability. అంతేనా? స్టెబిలిటీ అంతే కదా? చలో నేను రాస్తాను చూడండి అమ్మా. ఇక్కడ మెల్టింగ్ పాయింట్ విచ్ ఇస్ మేజర్ మెల్టింగ్ పాయింట్? సిస్ ఆర్ ట్రాన్స్? ట్రాన్స్ means here this is higher than this one. Is it clear? Boiling point, cis is major than trans. Solubility, cis is major than trans. Dipole momenta, here lesser than, sorry, cis is higher. trends. Stability. Is it clear? Is it clear, guys? ఓకే, మనం ఎప్పుడైనా ఎగ్జామ్కి వెళ్ళేటప్పుడు ఈ టేబుల్ చూసుకుంటే అయిపోతుంది, మనకు ఆ థియరీ పార్ట్ మొత్తం వచ్చేస్తుంది. వస్తుందా లేదా? ఎస్, ఎస్ ఆర్ నో guys? Any doubts? Any doubts? Do it fast. Srish, what do you want? Previous slide. Yeah, you take this screenshot. Srish. Ritesh, have you written? Ritesh, 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 where are you, man? Are you there? Ritesh. Srish, over? Yes, finish it fast. Ritesh. Yes. Yes, this table is over. This table is over. Afternoon also I will take class. Okay, be ready. Be ready, guys. Any doubts? Any doubts? Chalo. Now I will give some examples. You have to check it out whether it is a cis or a trans. Okay? Chesara? Whether it is a cis or a trans, you have to check it out. Okay, I will give few examples. Okay, so that you can write down Cl H H Cl C double bond Cl Cl H H C double bond Cl, then Br, then Br, and Cl C double bond CH3 CH3 H H CH3, then C double bond C double bond COOH H COOH H. No need to write down name. You can write down whether it is a cis or trans. That's enough. Okay, guys, అర్థమైందా? No need to entire write down that whether it is a that H H C double bond. Shall I write down? Yes, you have Satvik Anjali, you have to identify whether which compound is cis, which compound is a trans. I will give 5 minutes time. You have to finish it 5 minutes. Yes, finished. Chalo, నేను రాస్తాను ఇక వినండి ఇక. Same group, same side అనేగా. So it is cis. Opposite side. Trans. This one cis. అంతేనా? This one cis. Trans. Cis. Trans. Cis. Trans. This one. Here double bond. ఈ alkyl group opposite ఉన్నాయా same side ఉన్నాయా? This is opposite or same? Opposite. Trans. This one opposite or same side? Opposite. Trans. Trans. But this one both are same side na? అంటే ఇక్కడ హైడ్రోజన్ ఉన్నట్టు. హైడ్రోజన్ సేమ్ సైడా? సిస్. దిస్ ఇస్ ట్రాన్స్. దిస్ సిస్. సిస్ ట్రాన్స్. ఓకే చలో. దిస్ వన్ ఇప్పుడు చెప్పండి ఇక. సి డబుల్ బాండ్ CH సిస్ ఆర్ ట్రాన్స్. లాస్ట్ వన్ సిస్ ఆర్ ట్రాన్స్. Last one cis or trans. Not possible because these hydrogens are same, so not possible. Any doubts? Any doubts, guys? It is easy or tough today class? All are correct. How many members all are correct? How many members all are correct, guys? Good, excellent. Yes, I'm very happy today class. మీకు థియరీ పార్ట్ అర్థమవుతుందో లేదో అని కొంచెం కన్ఫ్యూజ్లో ఉన్నాను. బికాస్ ఆఫ్ ఎట్లయినా లైవ్లో చెప్పడం వేరు, ఆన్లైన్ క్లాసెస్ వేరు కదా. సో కొంచెం కన్ఫ్యూజ్ అయినాను. బట్ ఎనీవే యూఆర్ అండర్స్టూడ్. ఓకే, సో సేమ్ సైడ్ ఉన్నాయా ఆపోజిట్ సైడ్ ఉన్నాయా చూసుకోవాలి మీరు. దట్స్ ఎనఫ్. ఓకే, ఎనీ డౌట్స్? సాత్విక్ అంజాల్, రుత్విక్, భావన, భువన్ సముద్ర, ఎనీ డౌట్స్? Any doubts? Ritish, all are correct. Very nice, Ritish. Very nice of you. Just we can check it out whether it is all are same side or opposite side. That's enough. That's enough. Right, Karthik. Very nice of you, Karthik. Do it. ఎక్కడైతే మీరు రాంగ్ చేశారో అక్కడ కరెక్ట్ చేసుకోవడానికి ట్రై చేయండి. నెక్స్ట్ టైం వి ఆర్ నాట్ డూ దట్. అంటే సేమ్ టైప్ ఆఫ్ మిస్టేక్ చేయొద్దండి నెక్స్ట్ టైం. సో అలా ఉండాలి. ఒక్కసారి మిస్టేక్ చేసినామంటే నెక్స్ట్ టైం చేయొద్దు. ఎవరైనా తెలియకుండా చేస్తారు, నేనైనా చేస్తాను, నువ్వైనా చేస్తావు. బట్ నెక్స్ట్ టైం అలా చేయకుండా చూసుకోండి. దట్స్ ఎనఫ్. మనం హ్యూమన్స్ కదా, సో ఎట్లాగా మిస్టేక్ చేస్తాం. మిస్టేక్ని కరెక్ట్ చేసుకోవడమే బెటర్. ఓకే, ఆఫ్టర్నూన్ ఆల్సో వి డిస్కస్ ఎగ్జాంపుల్స్, maximum examples. Okay, don't miss the class, afternoon class. Again, మనం ఆఫ్టర్నూన్ క్లాస్ మిస్ అయిందంటే మనం దసరా తర్వాత మనం కలిసేది మళ్ళీ. అవునా? ఏ సార్ నో ఆఫ్టర్ దసరా వెకేషన్. సో దట్ ప్లీజ్ ట్రై టు అండర్స్టాండ్. Now 94 people are there. So don't miss the class afternoon session. Afternoon I will discuss maximum cis and trans followed by Z nomenclature. That is very, very important. Is it clear? Afternoon class is very, very important. Try to understand. Thank you very much, guys. Okay, take care. Thank you very much. Okay, again we are saying that again afternoon 2 o'clock, sharp 2 o'clock login gandi, sharp 2 o'clock. Okay, thank you very much, guys. Thank you, Mahati. Thank you. Yes, somebody wants to screenshot. Yes, I will show that slide number wise. Okay, please wait. This is a slide one. Mahati, take screenshot. Mahati, yes, anybody wants to screenshot, please take a screenshot. This is a slide one. Yes, this is the second slide. Up to 3 slides we wrote, that is a theoretical part, that is we are explaining. Slide 2, slide 3, slide 3, slide 4, Slide 4. Slide 5. 5. Slide 6. 7. 7. 8. 8. 9. 9. 10. 10. 11. 11. 12. These are the examples. Mahati, is it okay? Mahati, is it okay? Those who are finished, take a small break. Sir will come, I think 9:40 or 9:45. Okay, be ready. Thank you very much, guys.